two squares, a difference of two cubes, or a sum of two cubes? Well, we actually have a difference. We have a subtraction. So we know we're going to be either using the difference of two squares or the difference of two cubes. I can't write a squared as a cubed, right? So it's not going to be a difference of two cubes. So therefore, I'm going to want to look into the formula, a difference of two squares, which states one squared term minus another squared term gives us a factored form of a plus b times a minus b. But before I even can do that, I need to make sure that's a square term and another square term. So can I write 8? Is 8 a squared number? No. And is 32 a squared number? No. So immediately you could say, oh, well, you can't use the difference of two squares. But remember, the first thing we always want to do when factoring is factor out a GCF. Do these have a GCF that they have there? Yeah, the GCF is what? 8. So you can factor out an 8, and that's going to leave you with a squared minus 4. Now, is a squared a squared term? Yes. Is 4 a squared number? Yes. So therefore, I can simply say a. So what I'll do is I'm going to rewrite this as squared numbers. 8 times a squared minus 2 squared, or 2 squared. That means a equals a, and b equals 2. Right? Because you can see I'm squaring both terms. So a squared obviously equals a squared, and 2 squared equals 4. This is a difference of two squares. We're doing difference of two squares rather than difference of two cubes.
Oh, okay.
So now we just follow the formula. Yes, question?
Can we just put brackets instead of parentheses on parentheses?
You could put brackets in there as well. You can. Better? OK. So what I do is now that I know that this is in that format, so therefore, I can now rewrite this. I put a in for a, and I put 2 in for b. And there's my factored form. OK? All right. Now what I'm going to need you guys to do is we're going to get into some groups and work on some